Okay, so you should be able to see the schedule. So far, we have done with the meeting exam. So there's the first half of the semester already finished. So here, then we have 4 weeks of lecture and 3 on UML, the software design, and the last week is the unit testing, and also I'm going to I'm going to discuss how to use the Docker to use Docker for the developing environment. And after that is your term project oral. So today I'm going to assign the term project. Basically, your term project is the extension of your lab 6, 7, and 8. So basically, you start working on your lab 6, 7, and 8, and then by adding more diagrams into the lab assignment, and eventually become your term project. So basically, as you can see that 6, 7, and 8, these 3 weeks we focus on the UML, and these 3 lecture and the lab are related to your term project. So your term project oral presentation is scheduled on August 4th. So that's overall schedule. After that, you have self-study and followed by the final exam. So we are approaching actually. So the second half of the semester is going very quickly actually. Okay. Then let's working on the lecture. So today I'm going to give you the software modeling in the UML. So UML stands for Unified Modeling Language, is a model language to model the software. And also today we're going to the second topic of today is the requirement engineering. So we also touch that part as well. So these two are actually related. So I show you these slides in the first week of the lecture, showing the reality and the model. So we can see the model is a simplified version of the reality. So before we build the real bridge, we provide a design. So you can see that this design is actually a model it's kind of model of the bridge. So the engineering model is a reduced representation of some system. So for example, just by looking at the real product, you cannot tell what this system is doing. However, when looking at the model, you can tell what this system is doing. So the purpose of having model is help us to understand the complex system because the model is a reduced representation of some system. And also we can use the model to communicate ideas among engineers and with the stakeholders, with the manager, and so on. So the model can be a communication language. And also the model can drive implementation. And this is very true in the software engineering when we have the model and then we can generate the source code. Yeah, so you may see that, okay, now the AI can generate the source code. Why I need the model to generate source code? So the AI actually skipped the modeling and go directly to the source code. However, by skipping this part, it's very difficult for the developer to understand or to gain the overall picture of the entire software. So actually, in this AI days, the modeling become even more important for the software engineer to be in charge. Otherwise, we can just from the text to from the requirement to the source code, then there's nothing you can do. The reason there's nothing you can do is because you don't understand the code. But with the modeling, and so modeling is like something you provide that the AI need to generate the code according to the model you provide. So you gain the control of what should be generated. So the modeling, we can see that is abstraction of the reality, and the abstraction, of course, is simplification because they ignore the irrelevant details. And so this depends on what you try to present in a specific model, and what is irrelevant. So that's relative to the purpose of the modeling. Yeah, the purpose of different model, and then you reduce some irrelevant details. So so why we do the model? In addition to like the AI, we try to gain the control of the you try to in charge the project, and also it's cheaper to mess up the model than the actual product. So by analyzing the model, you can not only understand the complex system as a whole, and also you can do the simulation, you can do the checking, and so that you can catch some big issue earlier in the life cycle. So even you mess up the model, that's okay because you haven't committed the resource in building the product yet. So the model gives us some kind of the buffer before we actually commit to the product. And why we model software? One of the reasons is software becomes so complex, not a single person can understand, can manage this amount of code. So, and also the code is not easily understand by developer who did not write it. Even you write your own source code, after a few months and after a few years, if you go back to look at the code you have, you may not understand it, because the code is not easily understandable. However, the model is totally different because the model has a higher view of the software, so it's much easier to understand. And the model, we actually using the visual model. We are not using the text model. We're using visual model. So for example, like here, you can consider the source code as a textual model. So what you have is a line of code, and your source code may be in different file to connect them and make sense of them, become quite complicated. However, if we put then in a simplified form, the visual model, like the class diagram, so this is the same. Yeah, this is the same as the one I showed you in the previous slides. You can see that just by looking at the class diagram in here, it's much easier to understand the relationship of the code. And also you can, from the classes, you can see the name, the attribute, and the operation, even you do not have the detail of what this operation does, but at least you, on a higher level, you know that what component the class have and what the relationship of the class is. And then this is a kind of hierarchy, this is a high abstraction of the source code. And then on top of the class diagram, then you can group the multiple classes in a component. Then you have a component level of the structure, and on top of that, you can have a subsystem. Then you can have a hierarchy of the structure, giving you hierarchy detail of the software system. So here you can gain not only the overall view, but also the detailed view of the certain module, certain component, and different classes. So this one you can see that is much easier than just understanding the code. So that's why I'm saying that by using the model, you are in charge. Yeah, you are in charge. So by changing the model, then for example, you may like refactoring, move the operation around and change the relationship around, and this will fundamentally change the code. So basically, you can see that you are in a higher level in charge of the code. Okay, so what model should we use to model the software? Nowadays, we know that we're going to use the UML. So UML is a standard modeling language widely used in industry. However, before UML become the standard back to 1980s, there are many modeler fighting for we so-called the method war. So each has its own approach in software system and engineering design, and the UML is the legacy war. Yeah, legacy. Yeah, the war that occurred as a fusion of some of the competing methodologies. So you can see that UML taking inspiration from different tools and become the standard. So the UML goes through the history from 2003, earlier introduced, and now is the latest version, I believe, in 2017, is 2.5, and since then there's not much development. Yeah, because at that time people think probably I don't. Yeah, why I need the modeling language to model the software, but nowadays the UML coming back because in this AI days, and people we recognize the importance of using the modeling to gain control to better understand the system. Okay, so what do we learn in our 3 weeks? We are not going to learn every model. We only learn like we use this so-called 80-20 rule. 80% of profit come from 20% of product. So we are focusing on this 20%, 20% of the most often used model to answer most of the problem we may have. Okay, so this gives you the UML diagram type. In general, there's two kind of type. One is a structure diagrams to describe the static structure of the software. Of course, there's a different diagrams to describe different perspective in terms of the structure of the software. And another bigger category is for the behavior diagram. So this one focusing on the dynamic of behavior of the software. Of course, there's different kind of dynamic, different perspective in terms of like activity, interaction, the use case, and so on. So so here we have two big categories. So the one in the red color introduced in UML2. Yeah. So you may ask why we need so many diagrams. So please consider that each diagram provide a unique view into the system, and this is is corresponding to like we have a different stakeholder, and each one has a different view into the system as well. So you can see that the same software and different people will look at the different aspect of the software. For example, like the customer. Yeah, the customer is the one who use and probably need to pay for the software, and then they are focusing more on the functionality. Yeah, they just want to know that how to interact with the software. So that's what they're focusing on. Like you have a domain expert. So this person you can consider as like in the application domain. And so this one is more like a representative of the customer, and the customer may not describe what they need in a very clear language, but a domain expert, they can describe very clearly. So they have a different view. So here, business analysis, designer, marketing team, sales team, product manager, programmer, database administrator, and like the software tester or like a software working on the maintenance. You can see that all these people have some kind of connectivity with the software system, but they all have a different view. So that's why we and each diagrams provide a unique view. So somehow we can align the view of different stakeholder with different diagrams. So that's why we need so many of them. And each diagram is a different view of the same model. And hopefully we can align this view with the stakeholder. We can explain to them what's going on. Okay, so these are the diagrams we are going to practice in our lab 6, 7, and 8 in the coming 3 weeks. The first one is the use case diagram, and this one provide the functional behavior of the system as seen by the user. So this one is more like from user point of view, how this software function. And we usually use this use case diagram in the requirement phase. So yeah, so today we're going to discuss we will discuss the requirement engineering. So in requirement engineering, you can see that it goes through like two different phases. The phase one is the customer will usually to provide some kind of user requirement. That's very high level general language, like what a customer want. But that is very high level. You cannot use the user requirement to design the software, and we needed to further develop the user requirement into the system requirement. System requirement contain much more detail so that we can depend on to actually design the software and start writing code. And even in the system design, I mean the system requirement, some requirement item we still need a further clarification so that the use case can help. And also from the user requirement to the functional requirement to the system requirement, to describe some user requirement, we may also need the help of the use cases. So you can see that use case will help us to understand the system from user point of view. And class diagram, and even you have never used the UML or learned UML before, you may you may already know class diagram. Yeah, so class diagram is a most often used a statical structure to describe the software. Yeah, in terms of the class name, attribute, and operation, and the connection between the classes. The next one is a sequence diagram. So this one describes the dynamic behavior between actor and the system and between object of the system. So here we can so the sequence is actually to perform some kind of function of the software. So here is to analyze in order to operate this function what object involved and what method involved in each between the object and what parameter, what data being sent back and forth and so on. So this sequence diagram gives us a unique view into how this object interaction together to fulfill some functionality of the software. And a state chart diagram describes the dynamic behavior of an individual object. So some object, I mean some class in the detailed design level become very complicated. It become very complicated. So to game like internally how this class working, and we can use the state chart diagram. Yeah, so we define different state of the class, and then you see how this different class, how different the state being changed from one another, and what trigger the change. And the next one is activity diagram. This one we model the dynamical behavior of a system, in particular the workflow. So this one is also help us to understand like some complex logic, some kind of business model of the software. So we can use the workflow to see like how things go in parallel, and anyone may go into like go to different branches and so on. So the deployment diagram used to describe like how the software fit into the hardware. So this one, yeah. So also very so in nowadays, so when we deploy software, we're going to deploy to the standalone to the laptop. We're going to deploy to the cloud, and so here so this diagram help us to understand the deployment. So the requirement diagram is used to describe the requirement items, how they are related to each other. So you may hear about like when we change the requirement, now we need to change the code as well. So that's quite obvious. The requirement change and then the code being changed. But when we change the requirement, how do we know that which part of the code being changed? So you may think this problem is yeah, is very simple. Yeah, but actually in reality, you will see that is way more complex than you imagine. You change one requirement, and then you will see that there's many different part of the code associated with this requirement. And then this requirement may be related to other requirement. So you change one requirement, and then the other requirement may be affected. So you are so this requirement model, this requirement diagram is to try to connect the requirement items so that when one item being changed, then you know what other item I need to look at. And so that you have a bunch of requirement item actually affect by one single change. And then you can relate it to the multiple requirement item to the source code. You see that in addition to the code that directly related to the change, updated requirement item, I need to look at the code that related that are tied to the other requirement item as well, because these requirement items are related. So you will see that this requirement item will help us, this requirement diagram help us to understand the traceability from the requirement to the code. Okay, so this is a use case diagram as I showing you, like from user point of view, the user has the interaction with the use cases, but it's just a use case here. What I show you is just is just oval shape, the use case name, but the use case is not just a use case name. It's when you double click on this use case oval shape, it should pop up another window, ask you to enter more information. So most importantly, is like the workflow, the workflow that this list currently order involved, like a process ordered. So there's a steps involved in process order. So that's the key of each use case. So use case is not just a name. Yeah. So just provide the use case name doesn't provide much information. All the information is hidden inside this use case. By doubling click on it, should lead up to another window showing you the details. So the class diagram, as I showing you, that not only show the detail of individual classes and also show the relationship. Of course, different connection means different things. So we will spend some time here next week. Sequence diagram, you can see that this is a different object. And so each message here is a function call. Is a function call. You can see that in order to implement this function, there's so many objects involved, and how this function being called and so on. State diagram, as I mentioned, is this one is focusing one individual object. So these are the state. These are the state. And then these are the event to trigger the state change from one to another. So, and each event here is a function call. So basically, this event is associated with the method of that particular class. Activity diagram showing the workflow. In here, we apply this swim name to regroup the activities so that we don't change anything. We just regroup them so that you know that some actor or some class is responsible for this activity, and then this other class or object responsible for this activity, and so on. So that we can use this one, use the so-called swing name, vertical or horizontal swing name to regroup the activities. Deploy diagram, as I mentioned, showing the software and hardware, how they connect. Requirement item, requirement diagram show the connection of the class of the requirement item. So you know that if I make change to this one, I need to look at other requirement item as well. So here, you know that two immediate requirement I need to look at is like if I make change to this one, I need to look at the manage user account and the user detail, and of course remove user this requirement as well. So these three requirement I need to look at the same time, even I only change one, and then to see how they related to the source code. Okay, so these are the UML tools. So here you can look at it. There's some online tools, and the Visio also provided. So Visio provided by the Microsoft. You can play with it, and this one is not just specifically designed for the UML. So it's But this one can also use to draw the UML diagrams. What we are going to use is Enterprise Architect. I already post this software on Canvas, so you can download and install it. So we are going to use the Enterprise Architect. Okay, so before we go to the lab, I want to discuss the second topic of today is the requirement engineering and the use case modeling, how use case can help us to understand the requirement. So first, let's look at what is requirement. So the requirement are description of the system service and the constraint that are generated during the requirement engineering process. It may be range from the high level to the detail level. So you can see that requirement start from the high level, we call the user requirement, and then to the detail level. So this one, detail level, is the system requirement. So what we user requirement is like a very brief from user point of view, written by the customer or written for the customer, user provided by the customer. So these are very general. So system requirement developed from the user requirement. So it's a refinement of the user requirement. Is a structured document setting out a detailed description of system function, service, and operational constraint, functional, non-functional requirement. So this is in the system requirement. So let's look at one example of the user requirement and system requirement. What's the difference of this? So from user point of view, user may say, okay, I want to design a drug prescription management system. So one of the user's requirement is the system should generate a monthly management report showing the cost of drug prescribed by each clinic during that month. So yeah, user just have this general, general requirement. However, just by reading this requirement, you can see that there's a lot of things it's not clear. The system should generate it, then when should the system generate it? So you can see that we need to further asking customer some question. Oh, okay, and the last working day of each month. So now I know. So this to generate. So now I know when to generate. Yeah, to generate. And then a summary of drug prescribed and the cost and the prescription clinic should be generated. So here I know that some content. So in here it's just saying a general report, but it didn't show the content. So what should I generate here? So what in the report? So the user didn't provide. So here you can see that this system requirement not only specify the date, but the content of the report. And then the student should automatically generate the report for printing after 5:30 p.m. So here we further detail into what time to generate. And then the 1.3 is a report, give the detailed content of the report. So, and also furthermore, like if a drug are available in different dose, and then separate report should be generated. So you can see that user requirement is very general, and the system requirement is contain much more detailed. And then you may ask how I get this detailed information from. So this one is the bridge. We need to build a bridge between the user and the developer. Developer can develop based on the system requirement to design the software and to write the source code. They cannot just rely on the user requirement. The user requirement is too general. So we need to do. So here you can see there's a big differences between the user and the system requirement. How we can bridge the gap. That's what a system requirement does. So that's the requirement engineering does. So we needed to bridge. So we need to there's some kind of this strategy we are going to discuss later to bridge the gap. So you can see that the requirement engineering is to actually get from the user requirement to the system requirement, and people may take it for granted as a software engineer. So just tell me what to do, and then I'm going to do it. In reality, that's not the case. Nowadays, yeah, especially nowadays, the starting point must be concrete, must be very clear. So then your subsequent step is on target. Otherwise, if the starting point is deviated from the actual system, you will see that even the software you develop is perfect, but actually not what the customer wants. Then the project still a failure. So the requirement engineering is a very important step. However, it's the most yeah the neglected activity of software engineering. This one is actually very important. So in the requirement phase, there's two phases. One is a requirement elicitation, and the other is a requirement analysis. These two actually go back and forth. So in the requirement elicitation, we have the use case model, we have requirement system requirement items, and then in the analysis, we do some like a high level requirement analysis, and then we go back and forth and back and forth. Eventually, we come up with agreement, then we can move on to the system design. So that's what we focus on here. Before we can analyze the requirement, we need to first have the requirement items. So we can see that this one is a very challenging activity because this one requires collaboration of people with different background. User with application domain knowledge. So user just have a very high level idea what they want. And we know just based on what user provides is not enough. I need more information. So sometimes user may think, why don't you understand what I'm talking about? Why you still need this so many things? And then as a software engineer, you know that you need to know the details before you can actually design the software. Otherwise, the software you design may end up with something totally different. So the user has an application domain knowledge, and the developer with a solution domain. So the system design, how to deploy, how you do the cloud computing, how to use different like the AI things. But that user may not have this knowledge and what kind of database you need to use. So you have this solution domain, but the user has application. How we can make these two people working together to actually, satisfy both of them. And so bridge the gap between the user and developer is by telling the story. Yeah, using the example of this usage of the system. So, for example, like here, even I don't know what like content and what's the last day, I can just ask a user, can you tell me a story? Like how your daily operation. For example, like a system should generate this report, and can you tell me like who is going to generate report, and then this report is going to present your home, and then that person what he's expect to see in the report. So just by telling the story can what do we call the scenario? Oh, sorry. Oh, where is it? Okay. Yeah, telling the story. And then once you have a collect enough story, and then you can like the abstraction. Yeah, the use case is abstraction of different scenarios. Then we can document. Yeah, we can put in a document. So now let's see what is the use case. Yeah, what is the use case diagram does? Why this one can bridge the gap? Yeah, can bridge the gap. Because you can see that in general, the use case from the scenario is actually the example of the usage of the system. It's actually contain the step by step what it does. Yeah. So what the system try to do in this particular use case. So basically, the use case represent a sequence of interaction for a type of functionality. So this, for example, is a purchase ticket. And then we have actor. So actor is the one that so this actor is external. Yeah, it's outside of software system. is someone operate or something interact with the software. So this one we call the actor. Interact with some functionality. And then let's look at the actor is external entity of the system. Can be someone or can be something, can be the environment. And the use cases contain not just the oval shape with a name attached to it. Actually, the use case contain a name, contain the actor, contain entry condition, flow of event, exit condition, and special requirement. So in here, the most important thing is the flow of event. Flow of event define the activities, the task involved when I purchase a ticket. So when I purchase a ticket, so what a task involved, step by step. So this flow of event is the most important part of the use case. So when you, so in your lab 6 and your 10 project, when I ask you to draw the use case diagram, each use case must contain flow of event, flow of event. So this is the most important part for the use case. Okay, so in the previous one, we can see that for the purchase ticket, I list all the items of the use case. The name, the participating actor is the passenger. Entry condition, this one is optional. The passenger standing in front of ticket distributor. Passenger has enough money, and the exit condition, the passenger has the ticket. And here is the event flow. Yeah, passenger select the number of zone. So you can see that the number of zone. So this information is actually very important. We know that just by if the user just provided the user requirement, okay, the user need to can purchase ticket. Yeah, can purchase ticket. That one is too general. So in order to purchase ticket, then we need to define the number of zones. So this information is by asking the customer to provide a story, provide something. So we figure out, oh, okay, the ticket is related to number of Zoom. So this one is not initially available. It's not available in the first place. That's by talking back and forth, we know that number of Zoom. And then distributor display the amount due and the passenger insert the money, and distributor return the change, and distributor issue ticket. So you can see these are the steps involved. And there's another important thing about why we need this event flow. This event flow is not just to catch more information. The next week, when we discuss the class diagram, you can see that the whole software design, the classes structure, actually come from this event flow, come from the requirement, system requirement items. So these are the description of the system, how you use the system. Then we can use this to design the classes. So we'll show you next week. Okay, so you can see that when you have a multiple, so this one is just one use case. When you have a multiple use cases, then you can define the relationship of the use cases. So there's two most often used relationship. One is extend, and the other is include. So the extend is represent the seldom invoked use cases or exceptional functionality. So from here you can see that this event flow just describes one single usage, but doesn't show any exceptions. Yeah, for example, what if the user choose a number of zone and then leave? Yeah, then just leave. Where the machine here just waiting forever when the passenger already left. So this must be a timeout. So when users do something and didn't hit the cancel button, just left. So it must be a timeout. But here that doesn't show that there's a timeout. It doesn't show that there's a timeout. So you can see that the timeout is an exceptional functionality. So then we can use the timeout use case as an extended of this purchase ticket, and include relationship represent a function that is common to more than one use case. Yeah, let's still use this one as an example. Like a passenger can purchase ticket, and then just by working with the customer, we understand that the tickets has a single ticket, has a multiple card, has a weekly pass, and probably has a monthly pass, and so on. So you have a different choices of purchasing different type of ticket, and each one of the purchasing has one common task is collect money. So we can factor out this collect money and form a new use case. So you can see that, when we have multiple use cases, then we can have this extended. Extended is to describe a regular operation and then some like exceptional case, like a timeout, there's no change, customer click on cancel or like a machine out of order and so on. So these are the exceptional. Then we can use extended. If there's a multiple one similar use cases and then they have a common task, then we can factor out the one and form a new use case. So this one become the include. And also similar to the class diagram, you can have a general use case and more specific use cases. So this one can also apply. So here, here we call the parent use case and child use case, and then kind of, yeah. So here let's draw the use case example in here. This particular example describe like the general and the specific, and the included and so on. So in here you can see that dual use case diagram for ticket distribution system. This includes two actors, traveler and who purchase tickets, and a central computer system which maintain a reference database for the tariff. So here we can buy one-way, weekly, monthly, and update tariff. So here also including these exceptional cases, timeout, abort, out of change, distributed out of paper, and so on. So here you can see that I put this by one way, by weekly, by monthly, and update tariff. These are the regular operations. And then the traveler will interact with this purchase activity, and the central computer system will interact with this update tariff. And then since I have timeout aborted, out of change, out of paper associated with each operations, purchase operations. So here I can have a general distribution exceptions, and then this one, the whole structure extend these regular operations. So this one you can see that um, instead of have each one of them tied to each operation individually, we can use this structure. We can define a structure to extend these three, the use cases. So this example of use case diagram. And then once we have after a very painful activity, we get this system requirement. And then the system requirement actually has two categories. One is a functional requirement. One is a non-functional requirement. So functional requirement describe what system does. So for example, like each use case here is actually you can consider is a functional requirement, tell what system does. Non-functional is the aspect of system. For example, like the response time, like the server must be available 24 hours a day. Like yeah, so this kind of requirement. This one is also very important. Yeah, it's not only what you can do, but how you're going to do it. Some non-functional requirement define like the cost. Yeah, for example, if the server must be 24 hours a day, what this implies? So this implies you must have a backup server. So which means if the main server is going down, then you have a backup server. So this one shows the cost increased by double because the hardware cost increased by double. You have two servers instead of one. So you can see that some non-functional, not some, this all this non-functional requirement and this functional requirement altogether not only tell you what to do and how much the cost you have. Okay, so let's looking at before we move on, let's look at our lab 6. What do we actually try to do here? So the lab six, what I gave you is first, let me tell you, I gave you the user requirement. So these are the from user point of view, the software user try to develop. Yeah, but just by looking at the user requirement, you may think, well, yeah, I already have what I have. Yeah, I have enough information to start writing code. No, this one is you will see that this one is far away from you can actually write code. You may write a prototype from this system. I mean the customer description, but the final product is way far away from it because this one has a lot of uncertainties. Yeah, we need to dig out more information. So basically, in here, you are playing in the lab 6, 7, and 8, and in your 10 project, you are playing, especially in the lab 6, you are playing a dual role. First, you are like a customer, yeah, customer, and then you're going to looking at the problem from a software engineer point of view. Yeah, I need to dig out more details. So you are playing role as a customer and a software engineer. You're going to ask yourself your own question and what more information I need. So here, the purpose of this lab is not to test how good you are to ask yourself question to dig out more details. So that's not the purpose of the lab. That's not the purpose of the term project. The purpose is you of the lab and term project is that you know how to use the tool to help you. So even your final system requirement items looks horrible, that's okay. Yeah. So yeah, you will have time. You will have a because you are now just only probably this first software engineering course you take. You're going to take the 375, 376 in the future, and there's more software engineering course, and then in your internship and in your career, you will become more experienced how to get to the point that you can figure out the detail from the user. So in here, we're just telling you that, teaching you that how to use the tool. So even you need to communicate with the customer, you need some tool to help you. So here we are talking about a concept and then the tools involved. So here you can choose in the lab six, you can choose any user requirement item and then try to expand into three system requirement. So in our example, I show you here from this one user requirement, from this one user requirement, I give you like a 5 system requirement. So you can see that each of the requirement here is very easy to expand to 3. In reality, you're going to, in the real in a real project, probably this expansion rate is 1 to 10, or even higher. So, but here only just that you like extend for 3. You can choose anyone, and then use case diagram for the requirement in the step 1. So, for example, in here you have a 3 system requirement. And then you're going to make a decision here. Make a decision here. For example, here I have these are 5 system requirement, and the first one is quite obvious, and the second one is also quite obvious. I don't need further clarification, but the third one probably I need more information from the user. Then why don't I draw a use case? Draw a use case to dig out more information. So you can see that the use case is not applied to every single system requirement item. That would be too much. So probably you have like eventually you're going to have like a hundred use case. I'm sorry, 100 requirement item. 100 requirement item. Probably you only choose like a 10 of them. Then you need, then you believe that you need a further clarification from a user. Then you can draw the use case based on that a subset of the system requirement items. So that's what we're doing here. in lab 6, so here you got 3 system requirement, and then you draw the use cases, but one of them, at least one use case. So here you may choose, okay, I want to draw, I want to have 2 use cases to further clarify 2 system requirement items. But one of them, you need to uh, put more detailed information in it. So like what I show you in here, you need to put the event flow. But eventually, in your term project, all all the use cases, you need to put a detail into it. Yeah, you need to put a detail into it. Okay, so here I can give you another example of the requirement example. So this is the one user requirement, the expense creation. The software should allow user to create a new expense. So by the way, this software system is we call it Split Smart. Is for the sharing expense between individual and a group of people, such as friend, roommate, family member, or co-workers. So this one is inspired from a Splitwise. So Splitwise, if you go to, you go to, so Splitwise is an existing software. Basically, my lab and this term project inspire from this software to share the expense among the group. Yeah, for example, like if you have a roommate, if you organize a party, yeah, you organize a party and all the party member agree to share the cost, and then different person may just throw in the different expense, and someone rent is a party space, and someone purchase some stuff, and someone buy the drink, and then how we share the cost among all the participants. So here, so this software is going to do that. So everyone can create expense, and then add all expense up, and then reconcile, and then you can see that who is going to pay whom. So basically, this software is going to do this job. So I got inspiration from this software. So actually, this one is very useful. So first, this one has a user account. In order to use this software, you need to have an account, and then you can create a group. So this group, you can create a group, as many group as you want. So once you have an account, then you can create a group just for this party, and then you can create a group for the roommate to share the utility bill, or if you have a trip to somewhere, and then you have your friend go to the trip together, and you agree to share the cost, and then for that trip you can create another group. So you have a group management. You can like to manage group member, and then most important thing is that you can create expense. Yeah. So when there's expense, you need to create a group. And now, of course, some general information functionality like notify the people and approval workflow. If you create an expense, even overall everyone agree to share, but you cannot just create expense, and we need like the auditing people, so some kind of approval process to audit to see if this expense is legit. And then balance tracking to see like once you create the expense, then this you pay something and some other people may pay the expense for other things. So you need to keep track of the balance, keep track of balance, and then payment. Yeah, then you will see that who is own money to how much to another person, how much, and someone pay, but someone like not pay yet. So here you need to check the payment and then reconcile the balance. And the reporting, and here showing you that what is web-based, and then you need an app as well, and so on. So these are the from user point of view, very general. So your task one is to choose one of them and expand to 3. So here I just give you an example just from this one particular uh, user requirement and what I can expand. So here I can give you the requirement example. So this is a user requirement, and this is a functional requirement I provide. So they're all system requirement, but I categorize them into functional and non-functional, functional and non-functional. So should allow user to create expense, the user to specify the expenses equally split was split by percentage. So by default is equally split, but for some special expense may have some percentage, or some expense not involved with some. For example, like if you go to like a trip, and we agree to share all the cost, but for some for dinner, someone not participate, not join the dinner. So you cannot just let that person who didn't come to the dinner to pay for the dinner. So there's some exceptions. Yeah, some exceptions. So software should allow to update the image, so specify whether other user involved, allow the user to view. So this all the information is related to expense create. So expense create is from user is very general, but this one give you all kind of like detailed information. But how you get this information? So this is what I ask you to do. So here you are playing the dual role. From a user, okay, this is what I want. But then you can think of from the software engineer point of view, this information is not, I need to dig out more. So here is what you think of to dig out more information. Okay, so here the non-functional is related, for example, ensure 100% the balance adjustment should be accurate, and the software, the response time should be less than 2 seconds. The software should be uh, quickly, and the system should be retrieve response within 2 seconds for 95% user activity. Software should be available 24/7, and the uptime is 99% nine uptime, and so on. So these are some non-functional requirement. Yeah, we get from this expense creation. So from here, you can see that my expansion rate is way larger than 1, 2, 3. I have more than 10 requirement items from this one single user requirement. So I can see that the task for the lab 6 is quite straightforward. You choose one and then try to break it down into three system requirement. Each one contain more details. Okay, and then choose one to draw the use case and with all the detailed information. So let's looking at how to draw the use case using the enterprise architect. Okay. So okay. Okay. Let me open a new. Okay. Let me open a new project. You can here you can just give a lab 10 project. Lab 10 project. Yeah, yeah. Yeah, because the extension of your lab become the 10 project. So here I ask you, so what model I'm going to include it. So you know that in the lab 6 is only a use case. I just put a use case here. Put a use case here. And then this one is a use case model. We can give you some like a description. So here you can just delete all of them. Delete all of them, have a brand new. And then you can have a like here you can have the actor. You can give it this one is a user. Okay, so you can grab the use case here. For example, if the use case I examine my requirement item. I see that The should specify blah, blah, blah. So this one is a very quite clear, but I think that okay, this one probably this one is not that clear. I need to create a use case to further clarify this one, and the rest of them are very clear. But this one, from software engineer point of view, I need more information. So here you can say to create a new expense. Okay. So here you can create new expense. I create this use case, and this use case is specifically to describe this system requirement item. So, so this user, is going to create, going to use this one. So you double click on it, and then where I need to put the detail information here. So there's two ways to do that. One way is a simple way. Just in this description, you just put like a flow of event. Okay, the first the user log into the split smart like .com, something like that, and then user navigate to the navigate to the group, navigate to group, and navigate group user click on, for example, like a create expense button, and so on. So basically, this is you tells like what we're going to do next and so on. So this is one way to just in here you put the flow of event. So that's what that's one way to do it. Another way to do it is to go to the scenario, and then in here you can like step one, like log in to smart split.com, and then two and so you can have this step by step as well. So you can either way. So my suggestion is not using this one. This one is you're going to do this involve a lot of work. But the advantage of this one is you can have a basic pass, you can have an exceptional, you can have alternative. Basically, this one you can have a multiple scenario in one use cases in one use case. So this one is very beneficial. But in our practice, you don't have to get involved into this complicated structure. You just in this general show me what's the flow of event. Okay, that's what I need to see. So basically, in short, the use case is not just a use case name. So this one doesn't tell me anything. What I need to see is double click on it. I want to see what this one does, actually does, flow of event. Okay, so that's what you need to do in your lab, lab 6, and then in your 10 project, of course, you're not just targeting one use case, and then you need to have a system requirement of the entire thing, and then you choose like some use case, some requirement item to draw the use case, and then you enter the detailed information in here. Okay. Okay. I think that's it for today, because the rest of them is to describe the category of the non-functional requirement, because the functional requirement is kind of easy to understand what the system does. But the non-functional requirement, I know that probably is new for you. I'm not asking you to just become an expert in writing this non-functional requirement. Yeah, but just show you that some category has the usability, the reliability, robustness, and the safety, the performance, supportability, adaptability, maintainability, portability, So you just have the concept that the non-functional requirement is to describe this requirement, and this requirement has a profound impact into the software. For example, like the response time, yeah, like how quickly should respond. So this one depend on like if you have like 100,000 users, and then the response time you define is less than 1 second, then you can imagine like how to scale the software to uh to demand, I mean to answer the demand from so many people, and then you can provide the response so quickly. So you can see that all this non-functional requirement is not something we randomly we actually put into the requirement document, because you can see that the things you put in here cost money. Yeah, and also has a yeah profound impact into the design of the software, how to deploy it, and so on. So this is yeah. So here the in our lab and 10 project, you can just you don't have the burden, to think of the things after this non-functional requirement. You don't have to commit the money to actually developing the system, but you must have the concept like, okay, these things I put in here, yeah, put in here, going to yeah have a profound impact. So here is the non-functional. Okay, any questions so far?
Um, okay, I wanted to ask about the task 3 where it says use case scenario descriptions. Uh
Yes,
so is
that
that
part.
part, was that the Word file part, or
No,
is that
no,
like
the
inside of the
inside the inside user. So basically, it's this part, the flow of event.
okay.
This
So
part. Mhm.
all right. Okay. All right. So inside. Okay. Um
Inside.
so just step 1 is the one in the Word file then.
Oh, when you submit the zip file, you include the EAP file. So this one is the most important one, and a report, including description, requirement. Yeah. So in the Word document, the,
It was the
the
one where you had the expense where you split it up into several
right.
requirements. Okay, all right.
Yeah, so very similar to this one. So like here, I choose one user requirement, and then you provide like a three system requirement.
Okay.
Yeah.
And do we have to like split it up into functional and non-functional, or is it like
Uh,
okay to not
yeah,
specify?
yeah. You don't have to. You don't have to.
Okay. All
Yeah,
right.
but eventually in your term project, you're gonna do that.
Okay.
Yeah. Mhm. Okay. Any more question? Okay, if there's no more question, then we'll stop here. And let me see. Let me stop recording. Stop recording, and then I will see you next week.